In this video, we're going to look at static determinacy of structures. So let's start with a brief review from statics, looking at different support types. So this first one here is looking at a cable, and remember we can treat this like a rope. So force is only transmitted axially for cables. You can't push on a rope, you can only pull on it. So if we're going to draw the reaction on this member, it's just going to be along the length of the cable. Now for a roller, this is treated like a wheel, and it just rolls along whatever surface it rests on, so there's no horizontal restraint, which means there's no horizontal force either. We do have a vertical force due to gravity, so that will act vertically. However, for a pin, it is restrained horizontally, so we're going to have two reactions there, both vertically and horizontally. Now, a collar is kind of similar to a roller. You don't really see it as much in undergraduate. It does come up more in graduate school, and especially in mechanical engineering, it's a lot more common. But essentially, this collar just wraps around the rod or member that it's drawn on here, and we treat it as a frictionless surface, so it'll just roll along or slide along and doesn't transmit any force along this direction. However, similar to a roller, how there's this vertical force, we are going to have a reaction perpendicular to the sliding direction. So reaction will look like that. And then lastly, for a fixed support, we're going to have three reactions in total. So it's restrained vertically and horizontally, and it's also restrained against rotation, so it can't rotate like a pin connection can. So we'll have a moment reaction to account for that. Okay, so with that in mind, let's look at determinacy. When you're looking at a structure, there's two possibilities. It can either be statically determinate, which means that we have enough equations from statics to be able to solve the problem, or it can be statically indeterminate, which means we don't have enough equations. So what are those equations? Well, if you remember, we have sum of horizontal forces equals 0, sum of vertical forces equals 0, and sum of moments about a point equals 0. So let's just take a simple case here of a simply supported beam. And if we draw our reactions, the pin is going to have a vertical and a horizontal reaction. And the roller is just going to have a vertical reaction. So if we want to evaluate whether this is statically determinate or indeterminate, we first start with our number of reactions, which we're going to call R. And in this case, we have 3 reactions, so R equals 3. And then N is our number of members. So we only have this one beam. So for us, N is going to be 1 for this problem. If we had a second beam off this way, then this could be 2. Or if you have a truss or a frame, that number can increase. But for just a single beam like this, it's just going to be 1. So when we look at how does R compare to 3N, and this is because we have 3 equations of statics for each member. So for this one beam, we can use our 3 equations of statics. If we had 2 beams, we can use 3 equations for each beam. So this would be 3 times 2. We would have 6 total equations. In this case, we just have 1. So we have 3 and 3 times 1. So 3 equals 3. From up here, we saw that if R equals 3N, that means it's statically determinate. That means we can use these 3 equations to solve for all of our reactions, and we have enough equations to solve the problem. So we'll say this is statically determinate. So when would this be, or when would you have a statically indeterminate problem? Well, that might be a beam that is fixed on one end and has a roller on the other end. And if we start off, let's draw our reactions again. So we have the fixed end is going to have a vertical force, horizontal force, and it's also going to have a moment. So 3 reactions there. The roller, remember from before, is just going to have the one vertical reaction. Okay, so then we want to look at R compared to 3 times N. Well, for our reactions, we have 4 total reactions. 3 at the fixed end, 1 at the roller. So R equals 4. And N in this case is still 1. We just have one beam. So we end up with 4 is greater than 3 times 1, or 4 is greater than 3, which you may remember is the case for a statically indeterminate beam. So we will say this implies statically indeterminate. And what you'll often see is you'll be asked to classify how statically indeterminate it is. And for this problem, that is to the first degree. Which all that means is the difference between these two numbers. So we have 3 equations of statics, but we have 4 reactions. If we had 4 equations, then we would be able to solve this problem fully. So if instead you had a problem where R and 3N turned out to be, let's say, 5 and 3, then this would be statically indeterminate to the second degree. So if we had 2 additional equations, we could solve the problem. And that's really all that's saying. So in the next video, we'll go ahead and look at how we can apply this to frames and a couple more complicated structures. And then we'll also review the concept of stability.